Okay, question 58. For rotation about the C3 to C4 bond of 2-methylhexane, the book is asking us for a couple of things. There are actually 4 sub-questions, A through D. I'm only going to do the first 2, and I'm going to let you play around with C and D on your own. So for the rotation about the C3 to C4, that's the first bit that we have to address. So first, before we actually do that, let's draw 2-methylhexane. So hexane is going to be the root, so meth, eth, prop, but, pent, hex. 1, 2, 3, 4, 5, 6. So that's going to be our hexane. And then the next bit is we have to add our 2-methyl. So 1, 2, there's going to be our methyl right here. So there's our methyl group. Again, you could either leave it just as the point, or if you want to be more explicit, you can draw it with the Me. Or if you want to be even more explicit, you can add your hydrogen as well, if you want. Don't have to. So that's totally fine, or just leaving the hydrogen out and leaving the Me designation out is just as acceptable. So this is as good as 1, 2, 3, 4, 5, 6. Both of these molecules are totally acceptable ways of drawing this 2-methylhexane. Okay, so the first thing that we want to do is we want to do a rotation, and we want to do a rotation around the C3 to C4 bond. So let's go ahead and start numbering. So we're going to number 1, 2, 3, 4, 5, 6. So we're going to number from left to right and not from right to left. The reason we're doing this is this methyl group is given a higher priority than this hydrogen group would be given. So if we redrew this molecule and we put it over here, and let's say we wanted to get rid of this numbering system, this is the incorrect way to draw this. So if we had drawn, let's go ahead and put explicit hydrogen here. So this, if we had said 1, 2, 3, 4, 5, 6, this would have been completely incorrect. This would have been wrong. The reason is that the methyl group right here is given a higher priority than this hydrogen right here. And so because the methyl group is given a higher priority, that's the side that we're going to start on. We want to minimize the positioning of that methyl group. Okay, so this is the 2 position for the methyl group versus if we had numbered in this incorrect fashion, the methyl group would have been given a number of 5. So we want to minimize that number. So a 2-methyl is more preferred than a 5-methyl. This is not going to be the minimized way of saying it. Okay, and again, this is all convention. It's just a set of rules that people put aside and agreed to play by these rules. In reality, you know, in real life scenarios, the molecule doesn't care whether we call it a 2 or a 5. It's just a linguistic kind of way, so we all know what we're talking about. Okay, so unfortunately, you have to play by the rules. Okay, so the bond that we want to rotate along is the C3 to C4 bond. So this is the C3 to C4 right here. So this is the bond that we want to actually rotate. Okay, so what we'll do is we'll go ahead and draw our Newman projection. Okay, so here's our Newman projection, and the bond that I'm going to look down is this bond right here. This positioning is right here. So I'm going to look down this bond, but I'm going to orient myself with the 3 carbon in the front. So this is going to be our 3 carbon right here, and the 4 carbon is right behind it, and it's completely obscured by the 3 carbon. So there's nothing to actually number, but it's right behind that 3 carbon. Okay, so now we have to remember what is actually attached to this carbon 3. Well, we have obviously this isopropyl group here, so this is one group that we're going to try to attach. So this isopropyl, but we also have 2 different groups. We have 2 hydrogens also coming off of carbon 3. Okay, so if we're trying to draw the most stable conformation, obviously the way we've talked about it in class is that if you have this staggered configuration, the way that I've drawn it, this is inherently way more stable than having an eclipsed conformation. So that's the reason I automatically just drew it as the eclipse conformation and not the eclipsed. So we're going to go from here, and let's just go ahead and start attaching stuff. The first bit that we attach to carbon 3 really isn't that important because there's nothing to reference it to. So I'll just put the isopropyl group right here. So this will be our isopropyl group. Then we'll start putting our hydrogens here and right there. Okay, so that's that. So next thing we have to do is we have to attach groups to the 4 carbon. So again, the 4 carbon is right behind here, and these are the 3 groups that are going to be coming off of the carbon 4. So again, carbon 4 has 2 hydrogens attached to it right here and here. Okay, so we're going to have to attach 2 hydrogens and then a methyl ethyl group. So we're going to have to add this ethyl group as well. Okay, so again, we have 2 different positions we could potentially put the ethyl group, and it's the biggest group, so let's go ahead and play with that first. So let's just arbitrarily put it here. So this is our methyl and ethyl, so now we have our ethyl group attached. So the first thing, well, if we're going to do it that way, actually, we have to put our hydrogens here and here. So the first thing that you'll notice is that between this isopropyl and the ethyl group, we only have this 60-degree Gauss interaction. So again, going back to ranking interactions, Gauss interactions are more destabilizing than anti-interactions, but they're less destabilizing than these eclipsed interactions. So this is an okay configuration, but it's not the best. The way that we could do this, and the way that we can make this a little bit nicer, is to draw the molecule again. But in this case, we're going to change where this ethyl group is going to go. So instead of being in a Gauss configuration, what we're going to do is we're going to put it in an anti-configuration. So again, this is the whole point here is just we're trying to get the ethyl group as far away from the isopropyl group as we possibly can, just to minimize that steric clash. Okay, so now we have 180 degrees in between, and this guy is extremely stable. Okay, and so this is going to be a 60-degree Gauss, and it's not going to be as stable. Okay, so this is a little bit less happy than this guy. Okay, so this is going to be the most stable way that we can draw this molecule. And again, if we want to draw a Newman projection with the least stable conformation, all we have to do is reverse what we just did. So we're going to still draw the Newman projection almost in the exact same way, but we're just going to draw an eclipse conformation, and we're going to put the ethyl group right on top of the isopropyl group. So pause the video and see if you can draw that and double check your answer with mine. So here's our setup. So we're still looking along that 3-4 bond, and I'm just going to keep this first part constant. So we'll have the isopropyl up top, and we'll have the hydrogens down below. So first bit, if we want to make something really unstable, we're going to make it eclipsed. So eclipsed, unfortunately, is a bit more complicated to draw in a pretty fashion. So one thing I'm going to do here is I'm just going to replace that isopropyl group, and I'm just going to redesignate it to something a little bit more compact. So this is isopropyl, so it's the exact same thing. All we're going to do now is draw another eclipse conformation. We can't really draw it right on top because it would be extremely hard to see. But now all I'm going to do is kind of make this really, really close. So now what I'm going to do is put an ethyl on top and the 2 other hydrogens. So now this guy is, it's not eclipsed literally, but whenever you draw the bonds roughly parallel to the bonds in front, this is going to be indicative of an eclipse conformation. So this is good enough for me. If you drew it like this, I would totally understand what you meant, and it really doesn't matter whether this hydrogen's on top or on bottom. You can draw it on bottom, or if you really wanted to, you could draw it on top, just like this, and that would be fine as well. I get the point. Okay, so again, we have this eclipsed 0-degree interaction between the isopropyl and the ethyl, and this is going to be extremely destabilizing. Frowny face with a tear coming down. So this is the most unstable you could possibly get this guy. Okay, and then there are 2 more questions. I'm not going to go into them, but so take your time, look at question 58, and answer sub-questions C and D.